All right, in this one we'll do a quick demonstration of iPer 2.014 with small packets. That's sort of a common request, and these are CPU based systems, so we can do only so much performance on small packets before we get CPU bound. Um, with large packets you tend to be I/O bound, but with small packets tend to be CPU bound. For modern switches and stuff, they tend to use pure hardware solutions. But this is iPerf is a C code, C++ code, so it uses CPUs to do everything. So let's go ahead and turn on the UDP server. For this one, I'll turn on the I'll just use UDP. And I'll do another demonstration on other things on how to sort of test TCP with smaller either segment sizes or set the MTU on the interface. But this is just a UDP small packets. So with iPerf, you have the option to set the length of the write, which is the UDP payload length. So you have to calculate, the offset based on IPv4 v6 if you're worried about the underlying, frame length that's going to be used, and that's going to be dependent upon if it's Wi-Fi or if it's Ethernet. If you're looking at 802.11 frames or just 802.3 frames. But for this, so the standard length is 1470, which will drive to a 1516 length Ethernet packet. That includes the 4 byte CRC or 1512. But if you want small packets, just shrink the length. Don't go too low because there is some control information. Maybe 40 bytes or something like that. And that, remember there's overhead on top of that. And then if you do that, and let's see what happens with I1, and with UDP, go ahead and put a bandwidth. Actually, just do with UDP. And this is a 10 gig link, so I'll just put 10 gig. See what happens. Now this should be limited performance-wise because of the. Oops, using TCP. I forgot the UDP option. Okay, so this should be limited performance-wise because of the. It's just it's only doing it's doing the CPU base is 400. Um, 400,000 packets per second. I should probably put the E option to get better information on here too, to get you the how many 380,000 packets per second. So you get an idea on that. So that's really not all that great. I think if I do LSCPU, it'll tell me what my system is, and this system is running with 16 on cores effectively, 8 real cores, and then the 8 hyper mode, the hyper thread ones. So if you really want to get more performance, use more cores. So let's bump it up to 4 and see what happens. And that should improve things, and it does. Instead of having being limited to 300 and something thousand per thread, now you can get 4 times that, and I'm at 1.3 million. So let's go up to 8 because I know I have 8 real cores, so you should get better. And eventually you will top out based on the performance of your system, and because you're just going through the kernel and the kernel stack. So this is doing about 2.8 million packets per second. So I'm probably topped out. I'll go to 16 for grins just to see what happens and see if I get any better. Yeah, I'm doing a little bit better, 3.3 million packets per second. For a CPU based system, that's pretty good, considering everything. This is, like I said, this is our CPU driven, and these computers aren't most modern. I think with modern you can get that better and 100 gigs. I don't have access to those machines, but so you get an idea. If you want more packets per second, just set the -L and use -P for parallel.